Good morning, dear audience. I'm bouthe TRAD, PhD student at Beji Mukhtar University. Today, I want to share with you a little part of my work. So, the topic of my presentation is the optimization of culture parameters for a high rate of ethylene glycol biodegradation. Firstly, I'm going to give you an overview of my subject, which I've briefly divided into four main points: introduction, material and methods, results, and finally, little conclusion. First of all, I will talk about ethylene glycol compound, that is inorganic chemical compounds characterized by low volatility and colorless, syrupy liquid, and it's measurable with water and some solvent and slightly soluble in ether. Ethylene glycol is used in a variety of consumer and industrial applications and also frequently used as a basic building block for other chemicals. On a worldwide basis, approximately two-thirds is used in manufacture of plastics, automobiles, plasticizers, and product and pharmaceutical products, and with further are used as an antifreeze. The terminal effect of ethylene glycol on the environment has become increasingly evident in the recent decades due to the significant concentration that are released in the soil and aquatic ecosystem. In addition, the high density of ethylene glycol and high water solubility influences their fate and transport in the groundwater and subsurface, produced inhibition of germination of terrestrial organisms. Furthermore, several studies aggregate that the ethylene glycol has a high level of toxicity toward aquatic organisms and human health at a high degree of ethylene glycol accumulation. According to this information, the pollution by this molecule and their toxicity must be prevented. In this context, microbial degradation of ethylene glycol is an eco-friendly strategy that represents a great opportunity to manage the pollution of these compounds with no adverse impact and risks. Nevertheless, the rate and the extent of biodegradation can be limited by many factors, such as temperature, biomasses, densities, and the level of ethylene glycol released in the contaminated sites. The objective of the present study focuses on the effect of ethylene glycol concentration on the rate of the biodegradation and microorganisms growth. Let's move on to the next topic, which is the material and methods. So the water and soil samples were collected from aquatic system rich on plastics and their derivatives waste and municipal landfill area in Annaba region. The samples were diluted and measured on an appropriate medium and condition to isolate the bacteria and fungi strains. The biodegradation test was performed with 1% of ethylene glycol that had been added to flasks containing minimal salt medium. Ethylene glycol degradation study was carried out using the microbial strains individually. Each flask inoculated with 1 ml of 24 hours old culture for bacteria strains and 72 hours old for fungi grown on ethylene glycol supplemented medium as a salt carbon source. Flasks non-inoculated served as the control. All flasks were incubated on a rotary shaker at 33 for bacteria and 28 for fungus strains for 25 days. Study of the ethylene glycol effect concentration on microorganisms growth. The test was carried out on nutrient broth fortified with different ethylene glycol concentration as a substrate. After the inoculation of flasks were incubated 72 hours at 30 degrees and 28 degrees. This leads us to the results, which still preliminary unfortunately, and the strains unknown yet. As you can see in the figure 1, summarize the results on the comparative growth profile study between the soil and water microbes. The fungi and bacteria strains isolated from the soil showed the highest ethylene glycol biodegradation rate than the bacteria and the fungi strains isolated from the aquatic medium, and they showed their potency on ethylene glycol degradation and used as a salt carbon and energy source. And also highlights that the fungi strains have a highest rate biodegradation of ethylene glycol than bacteria, which is described in the figure 2. So to put another way, the fungi strains were having a better ethylene glycol assimilation than bacteria, despite bacteria have a faster adaptation rate to the laboratory conditions. In spite of that, the rationale of this experiment was to investigate the influence of ethylene glycol concentration on the microorganism's growth in order to increase the ethylene glycol biodegradation rate. In the figure 3 demonstrated that the microorganism's growth increased with the increase of the ethylene glycol concentration between 1 to up to 3% of ethylene glycol, and also showed that the highest microbial growth was shown by the fungi strains in the medium containing 2% of ethylene glycol. On the other hand, more than 3% of ethylene glycol on the medium, it becomes more toxic and decreases the microbial growth and of course will be decreased the rate of biodegradation. So to sum up the results, after a short period of adaptation to the laboratory conditions, the microbial attack was quite supportive of the fact that the indigenous microbial is good enough to use the ethylene glycol for cell growth and multiplication. I'd like to draw your attention to an important point that the time required for complete biodegradation is varied with various inoculum sources and their densities, also the substance concentration and the inoculation conditions. As I mentioned before, that the soil microorganisms more efficient than the aquatic microorganisms on the ethylene glycol degradation. But unfortunately, little attention has been given to ethylene glycol fate in anoxic habitat and billions of pounds discharged in the environment annually. To conclude, I'd like to briefly mention that the ethylene glycol is known that as biodegradable compounds, their hazardous is bound to the significant amount seasonally discharged into the soil and groundwater. Therefore, the necessity of environment-friendly disposal polishes designed for the biodegradation of ethylene glycol and their polymers waste is tremendously crucial and needs an important consideration in the ecological balance of materials. This investigation was conducted to show the importance of aquatic and soil microorganisms in the development of bioremediation techniques for the biodecontamination of marine and soil environment contaminated by this chemical substance, using strains typically present in the contaminated sites. And there is a need to develop more remediation techniques that will preserve the environment without any ecological or health risks issues. That's the end of my presentation. I hope that covers everything I want to say about my subject. Thank you very much for being such an attentive audience.